Let's find the volume of the solid formed by the curve y equals 4 minus x squared. Here's the graph, and here's the curve y equals 4 minus x squared. Now we know that this curve will revolve around the x-axis. So it will extend down here. So how would that look like? It will look like this. As it rotates about the x-axis, it will go this way and then go back up. So here's the solid. Okay, now how do you find the volume of this solid here? You can see this solid is filled with infinite number of small cylinder discs. Okay, let me draw one of them. Now here's a small cylinder disc, and this solid is filled with all of this here. I just draw one as an example. Now, what you can see that as, if you can find the volume of this small cylinder disc, and you just have to add it up from 0 to 2 here, then you can find the volume of this solid here. Okay, now first of all, let's look at this cylinder when it's flat. It will look like this. Okay, assume that's how a cylinder looks like when you look at it from the side. Okay, so now, what's the height of this cylinder? Here, right? That would be h, the height of the cylinder. What's the radius of this cylinder here? Would be here. From here, from the center to the side. So that's the radius. What's the formula for the volume of a cylinder? That would be now we will use subscript C and cylinder. So that's the volume of a cylinder. Pi r squared times h. That's the formula for the volume of a cylinder. Okay, so now we need to add up all the volumes. We need to add up the volume of all the cylinders that fill up with this solid, and then we will find the volume of this solid here. Now, what's the equation for the volume of one of this cylinder disc here? Now we know that the radius of this cylinder disc here is from this point which is the x-axis. That's the center of the cylinder. All the way up to here, right? This point. So that's the radius. And this point here is the curve, right? Every cylinder here, every cylinder disc here will be touching the curve y equals 4 minus x squared. So the length of the radius of each of this cylinder will be the y value here of the curve. So the radius of one of this, okay, I should say that the radius of all the cylinder discs here will be y. Okay, so I can rewrite this. Now let me write this. The volume of the cylinder disc will be pi times RSY. So y squared times, now h. What's the height? Now, we know that if we put it flat, the height will be here, right? This small edge here, right? So now, if it's vertical, we know that the height is here, this shaded area. Now, the thickness of the cylinder disc is infinitesimally small. Since this is the x-axis, so since this is infinitesimally small, we will call this length just dx. Really, really small value of x. So the height of the cylinder disc will be dx. So this will be dx, right? Now, that's the equation of one of the really, really small cylinder disc here. But we have to sum up the volume of all the cylinder discs from 0 to 2 here. Then we have to do an integral, right? From 0 to 2. However, we're integrating dx here. This is y value. So we cannot just integrate like this. We have to write y in terms of x. And that will be easy because we know that this curve here is y equals 4 minus x squared. So I can rewrite this as integral from 0 to 2 pi times 4 minus x squared dx, right? And that's the volume of this solid here. Now, we just have to evaluate this integral here. Now, the volume is equal to integral from 0 to 2 pi times, this is basically 4 minus x squared times 4 minus x squared dx. Now, let's expand this. Pi times 4 times 4 is 16, minus 4 times x squared is 4x squared, now minus ax squared, now x squared times x squared plus x to the 4 dx. Okay, we know that pi is a constant. We can move it out of the integral sign. So that's equal to pi times integral from 0 to 2, 16 minus ax squared plus x to the 4 dx. Now, this is just the basic integral because it's subtraction and addition sign here. So we know that that's equal to pi times, now add 1 to the power divided by a new power. So in this case will be just 16x minus, now add 1 to the power divided by the new power. So ax now to the power of 2 plus 1 divided by 2 plus 1 plus add 1 to the power divided by the new power. Now evaluate at from 0 to 2. Okay, now let's rewrite this. The volume is equal to pi times 16x minus, that is a over 3 x cubed plus, that's x to the 5th divided by 5. Evaluate at like from 0 to 2. Okay, now we can distribute the pi to each term. So we have 16 pi x minus a over 3 pi x cubed plus pi over 5 x to the 5th. Now, all of this evaluate at 0 to 2. Okay, so what's that equal to? Okay, let's do it here. The volume. So we have 16 pi times 2 minus 8 over 3 pi times 2 to the power of 3 plus pi over 5 times 2 to the power of 5. Minus 16 pi times 0 minus 8 over 3 pi times 0 cube plus pi over 5 times 0 to the 5th. Okay. The volume is equal to, now, you can just multiply the number and then keep the pi and then find the common denominator of each term and then group them together to get the exact value. But I'm going to write them out in decimal so that we can get the approximate value without a pi. Okay, so 16 pi times 2 is 100 point, approximately 100.53 minus 8 over 3 pi times 2 cube is approximately 67.02 plus pi over 5 times 2 to the 5th, approximately 20.11 minus, now all these are 0, so 0 minus 0 plus 0 will be 0. Okay, so that is equal to approximately 53.62. So the volume of the solid is approximately equal to 53.62. That's the volume of this solid here in the magenta curve. Hope you enjoyed this video. Don't forget to subscribe to my channel. Thank you.